are actually going about and accomplishing their goals and objectives to carry out their missions. Because what I want to do is I should be able to contextualize each one of the stages in various different attacks so that I can identify, based on the data that I have available, where should I be threat hunting and focusing my efforts that are going to align with how we know these adversaries operate, because that is a area of threat intelligence that is, going to be very vital in the future, as we move away from indicator driven threat intelligence to really getting into the weeds of understanding adversary operations and using that to actually drive what we're threat hunting for. So how do you do that? So how do you create test data? So like there are things like the Atomic Red Team, which is a great project, and that allows you to create some data that is associated or very similar to what attackers are doing on a real world. Now, I think it's great, and that's a good place to start. Although instead of like popping calculators anywhere, I found that what has been more effective is to actually create some realistic data by getting as close to the real thing as possible. I really think that we should be arming our defenders and our threat hunters with offensive security tools so that they're able to recreate as realistic data as possible. I understand that that's not always the easiest thing to do, and in some cases those offensive security tools actually have language in their license agreements that you will not use their product to actually specifically do detection engineering on. So how do we get around that? Well, I've been working with the Velociraptor project for quite a few years. I'm a huge fan of it. If you're not familiar, I'll link to it in the description here. But it is a threat hunting and digital forensics and incident response tool that allows you to collect data at scale and a client service model to collect various different artifacts, to find evilness in your networks. And it's fantastic. Shout out to Mike Cohen and the whole VelociDex team. I think it's one of the most important security tools of the last 5 years. But through getting more and more entrenched and exposed to the Velociraptor project, I started to realize that there's a lot of capabilities within the Velociraptor platform that could act like a C2 framework, and we're able to carry out some very similar behaviors. And with a little customization, we're able to create some really realistic telemetry on boxes like an adversary using the capabilities within the platform. And the bonus is that now you have a single platform where you're doing your threat hunting development and your testing in the same thing. So you get this really easy iterative process, and you can line up a threat hunt to its test to make sure that here's my detection based on this test data, and it's all within the same thing, so you can run them back and forth, and it gives you a really easy way to operationalize the design and management of your threat hunts going forward. So if we take that example of that ransomware attack, I'm not going to run through the whole thing because it would take forever, but we have like the first 3 stages of here. We can each boil down some of these artifacts into, or some of these stages into Velociraptor artifacts, and then use the platform itself to create some of that telemetry. Now, like I said, I'd like to keep things as realistic as possible. So where applicable, I've done things like we're going to go through this example right here. We're actually going to infect this system with a modified version of the Valak malware, defanged, if you will. So I removed the C2 stuff, modified it a little, but it's still going to execute. It's going to set its persistence. It's going to tuck a copy of itself in the registry. It's going to download the second stage tool set, so that in this case, that's the network support manager. The network support manager is going to set its persistent, execute. We're going to use that to create a PowerShell-based backdoor. We're actually going to download and compile that on the fly. We're going to do Mimikatz. We are going to switch the context of the domain administrator, do Active Directory recon, and then actually do a lateral movement, which I think this is actually pretty cool. The way that we do lateral movement is we're actually going to, instead of like using PSExec or Cobalt Strike and we're moving along like a beacon loader or something like that, we're going to use the Velociraptor installer as our remote tool that we're going to move laterally with, and then pop a shell, more or less, basically install the Velociraptor agent on another box to move laterally to make sure that that telemetry looks realistic. So without further ado, let's show you what I mean by trying to run through this. Everyone collectively knock on wood to see if we can't do this in the first try in RedRaptor is what I've been thinking I'm going to call it, although I will take suggestions. Initially, we were calling this Red Team, but I think Red Raptor sounds cooler. But you know, let me know. Let me know. So the first thing we have here is we ran as user, right? So like you would see in the real world, we want to operate under the context of a user who got phished. So we have one system in here, and that's going to be our first system, and we can see that the Velociraptor service is running as J Dwyer, which is our user account. So we're kind of good to go to move on to the next thing. Oops. Okay, so let's go ahead and infect this box with Valak, and then use Valak to download and the second stage. So we're gonna see this thing. It's running right now, and as things happen here, we'll start to see some things happening on the other side. So if we pop over to our system here, we can see here, boom, downloaded our loader. It will have set its, here's our classic sound, which is its persistence mechanism. We should, so this is, there's a second stage loader right there. So this was a encrypted archive that contained the network support manager. If we refresh here, we can see it created its registry key. Yep. Right here, this is the defang part. Like I just modified it so it wouldn't do that. Here, so what the second stage after it checks into its C2, gets the second stage, which was the download the backdoor, which was the network support manager, which was automatically extracted through alternate data streams. And now we're moving right along. So if we go right back to, let's see, go back to our slide deck here, we can see that we ran that artifact and was able to replicate all this activities to get a realistic representation of what that would look like in terms of data on the box for us to threat hunt about. And now the next thing we want to do in this stage 3 is we want to migrate out of network support manager into our PowerShell-based backdoor. And in network support manager, there's a utility called remcmd stub.exe, which allows, you know, for the legit use of this tool, allows you to basically run a command shell remotely. So if we go back to our system, we are going to use, I'll show you in here. So we're actually going to use remcmd stub to download and compile and execute a PowerShell-based backdoor. So and I'll show you down here. So this is all this stuff is being pulled from the Velociraptor server as well. So there's basically a library of utilities for, you know, malicious and the like, where it's reaching out. So this is all not going out to the internet. Well, in some cases I do. It really depends on how you want to configure this, but everything's staged on there so I can control what the payloads are actually going to be if I need to modify things. So we have our PowerShell-based backdoor. It should be able to see something now where it downloaded. So here it downloaded our CS file, compiled it as servicehost.exe. Through there, it loads a PowerShell-based backdoor, and we can see we have here's our backdoor running in PowerShell. And that was just all carried out automatically through Velociraptor, but actually doing the malicious activity on the endpoint and creating real telemetry. So now that we have our PowerShell-based backdoor, we're going to use that to harvest some domain admin credentials using Mimikatz. So let's run this now. And this is going to use that PowerShell-based backdoor, and it's going to reach out, grab, invoke Mimikatz or Mimikatz. I think it actually is just going to load that executable in memory, if I remember which artifact I actually used. And then it's going to try to dump the domain admin credentials, right? Because in this scenario, there's a service account that's running on the workstation, which is the enterprise backup service account, and that service account is a domain admin. You know, very, very similar, and we run across that situation often in the real world. And in this example, that's what we're going to do. So next thing we're going to do is grab those credentials. So if we see, we should get some results back, and hopefully, yeah. See, like the way I have this setup is that you're actually going to grab your Mimikat's actually going to run, and then you're going to get those credentials back. So I can use that because I don't want to fake it. I want the real thing, right? Because I want to be able to have threat hunts designed off of real telemetry. So I can use that, and I for the sake of time here, I already have that hash already set here, and we're going to do pass the hash on using the domain administrator account that is that we're able to grab in Mimikatz, and I'm going to pass hash start a new process, which is going to allow me to switch. And in that case, what we want to do is, because we were able to harvest those credentials, create a process with the domain admin account, we want to execute Velociraptor in the context of that domain admin account. So we can do that just like you would in Cobalt Strike when you pass the hash, and then you basically set that beacon to run as the domain admin. We're going to do the same thing here with the Velociraptor data. So as long as this comes back, we'll check it. And as long as everything worked as, yep, we can see. Do you see that? So this log on as changed to service_backup. We'll restart that just so we have the new creds. And then I have it set up so you can do that from the console as well, but it's no big deal to do it here. So now, like because we passed the hash, we want to switch our context because we want to be operating as a domain admin through our RedRaptor artifacts here. So now that we've been able to harvest those creds, execute those creds, the next thing we're going to do is do our set persistence, because right now we're running basically in memory of this PowerShell. If that process dies, then we lose our PowerShell-based backdoor. In the real world, this was actually a Carbonac backdoor manifested in through this PowerShell, which reflectively loaded, kind of basically did exactly what we did, except for downloading the PowerShell loader. It has it packed within a PowerShell script in like this encoded Klingon Bob that runs as a scheduled task. So we're going to do that now. And this will run, and basically this is going to set our persistence for our PowerShell-based backdoor, and this should create another scheduled task. This error message is just for because I defanged the malware, so it's actually not running. So here's our update definitions, right? So this is our Carbonac-based backdoor, and it's running this batch file, which then calls a PowerShell. And as long as I did this right, then we should be able to go to this path, and we'll see that it had downloaded Windows System Apps. Yep, and here's our PowerShell-based backdoor, and it's loaded through that batch script file. So we're actually creating real-life telemetry without popping anything too malicious, but just recreating very similar to it. So we're running as domain admin in the context. We have 2 base backdoors, all replicated. If we go down to our little map here, we're down here. The next thing we're going to do is do some reconnaissance, and you can do this with AD Recon or AD Find. I think in this one we're actually doing AD Recon, which is going to download the PowerShell. Yeah, AD Recon. But you know what? Let's do something offline. I'm going to show you how easy this is. So let's use AD Find, and we should have that. So here's our and look, so we were in this case, we were looking for domain admin accounts in other than the one that we already had in the domain. So here we can see enterprise backup. This is the service_backup. This is us. So we know that we're a domain admin. We know that there's a user account named John Dwyer and then the actual built-in one. So we have a collection of all the domain admins. Now that we know we've run AD-find, we know that we are domain admin. So what we're going to do is we're going to move laterally to a system. Now, in the real world, excuse me, I just coughed. In the real world, they probably do further reconnaissance to actually find the target to laterally move. But for the essence of time, so I don't keep here for 2 hours, we're just going to assume that I did a query. You saw that I can query Active Directory through AD-find. I'm going to have my target. And this thing I think is pretty cool. So very common in real world incidents, you'll see that they'll find a lateral movement path, Cobalt Strike, Metasploit, all the kind of PS exec, right? Those leverage things like admin shares or to create a new service, so SMB, either copying a loader over like a beacon loader or doing something where it's just purely PowerShell based where it runs some shell code as the service executable, and then that spawns a beacon. Probably one of the most common lateral movement techniques that we have seen in the real world, and so we want to replicate that. So what this actually does is, I think this is pretty cool. So I created a custom self-extracting executable, which will then be copied over to the admin share of our remote target using our domain admin account, then create a new service that is going to execute that custom executable, runs that as a service, which then installs Velociraptor to run in client mode. So whenever, that's essentially like popping a shell on a remote host using very similar techniques, but I'm not using any malware, right? I'm not actually loading a Cobalt Strike beacon, but I'm going to get the exact same telemetry as I would in the real world. So, moment of truth time. If we are lucky, and I search in here, see, this is what I'm saying. I do this live. Okay, so we have a finished one. Did it actually work? Did it actually work? Oh, it failed. We copied it over. Oh, it already exists. See? So let's check it. Ah, there we go. It did. I just ran it 2 times. Here we go. So we moved laterally. Like I said, I always do these lives. You're going to see me mess up a lot as we go forward. I don't care because now you know that it actually works. No jump cuts in this. I actually show that it works. So what we did is we actually moved laterally on that system to demonstrate that, we're going to move laterally over an admin shares just like they do in Cobalt Strike or PS Exec or Metasploit or anything like that. So through that, the next thing we can do is come back through and actually do some detection on that. So that's the cool part, is like we created the telemetry. Now we can go back through and create Velociraptor artifacts to hunt for those behaviors all in the same process. So I can create the VQL query to query out and say, give me that stuff back. For, the lateral movement, we would be collecting system event log 7045, looking for file name, of service file names that had admin dollar, C dollar, or IPC dollar, or PowerShell, or ComSpec in the file name, bunch of keywords, and get that data back, and I should be able to find it pretty easily. Another really good one we could do this again. See, I have all these different ones built in here. So let's do, in this case, let's run invoke DC, let's DC sync our domain controller. Here's a good, I'll show you exactly how it's going to work. And we're going to do on the workstation, and basically we're going to DC sync our domain controller so we get the KRB TGT hash. Stop. Just to come clean up. And let's run it. And hopefully, look, boom. So we DC synced it right through Velociraptor. And the cool thing is now we can go back and you can see we have a detection there too. So based on that, we can then, if we have this, the client running on the domain controller, run the detection part of this to run this artifact right after we create the telemetry, and then grab the event log and get that back. And now we're like really have sort of like a DevOps iterative process where we're able to create the test, create a detect, create a test, create a detect. Actually, let's do this right on the fly while I have you here. We'll take 2 seconds here to do some work here. And what I'm going to do is I'm actually going to I'm going to laterally move to I had some of the stuff hard coded in there because, you know, real world examples, and it gets hard enough to get things to work in the best of cases and not whenever we are. So I'll show you. Okay, so basically what I'm doing is I'm just going to hard code the domain controller as the target for our lateral move, and now, yeah, so now let's do a new one. And so this should work, right? It worked last time. What could go wrong? Let's see. If we move over to our domain controller, do we see? Oh, yeah, so here's our installer, you know, got moved over to C dollar as it normally would. And do we see the service start over here? Look, and so it installed the Velociraptor service just like it normally would. I'll just start it so we can. I'm just going to start this manually so to make things faster. Okay, we go back, stop that lateral. We should see our domain controller in there too. Awesome. What I want to do here, so I'm going to add a label, and we'll just call it domain controller. And we're going to go back and then DC sync detect. And as long as I did everything right, we should get some data back. Boom. And here we go. Here's our detection. We see service underscore backup with event ID 4662 is, you know, the #1 detection capability to look for DC sync in the event logs. We just rapidly did that. We created a test data